Welcome to the cloudonaut podcasts. We are your hosts, Andreas and
Michael Wittig. This podcast is about all things AWS, and we share our experience with AWS in our day-to-day work. This is episode number 69, and we are recording this on February the 2nd in 2023. In case you're watching this live on YouTube, feel free to add comments with your questions so we can answer them later in the show. Besides that, you can reach us on LinkedIn, on Mastodon, on Twitter, as well as via email, so feel free to reach out to us with your questions.
Yeah, and before we start, here's a message from our partner. Are you looking for a new job? AWS expertise is in high demand. Our partner Demican is looking for a cloud operations lead working remotely from Germany or the EU. So you could be the one who leads a growing team of cloud architects and DevOps engineers. So hire new team members, manage service delivery. That's all what this role is about. Demican is one of the largest technical consulting teams here in Germany, and they have been focusing on Atlassian and our full service provider here in Germany. And now they are building a new business division with a focus on cloud technologies, which you can join here. So check out that opportunity. You will find a link in the video description and the show notes. Okay, Michael, so let's start. So over the past week, I've been working on a few things, and I want to share some of my learnings with you, and of course, our listeners as well. So the first thing is, I think at the beginning of the year or at the end of last year, I created CloudFormation templates for deploying a Mastodon instance to AWS. And we have been using that for social.cloudonaut, our own Mastodon instance. And there was one thing on my to-do list for quite some time now, which was adding CloudFront in front of the S3 bucket that stores all the assets. So user profile pics, user uploads, stuff like that. Mm-hmm. I wanted to fix that because there was also a bug related to this S3 bucket thing, and basically all other instances and users pull the images directly from our S3 bucket. I wanted to fix that. So I created a CloudFront distribution, and I was modifying the bucket policy and so on. And then what I realized is I really run into a very strange S3 permission thing because as soon as I switched to my new setup, I had a bucket policy in place for granting CloudFront access to the bucket with this, is it called CloudFront Origin? How is it called? I forgot the name.
Origin access.
Origin access. So only CloudFront can access the objects in the bucket. I had that. This was working fine. So delivering the assets was working, but then I tried to upload a new image to attach it to my post, and this failed. And after digging into the logs of the Mastodon instance, I found out, this is because of an S3 denied error. So access denied error when uploading the file to S3. But I really couldn't find out what was going on there. So usually I fix IAM and S3 permission errors in a few minutes, right? Because that's what I probably do every day. But this one was really tricky. It took me hours to figure it out so what would you check, Michael, when you have an S3 permission error? So it's a container running on Fargate. It needs to access an S3 bucket. So where would you start checking the permissions?
I would start the IAM role of the Fargate task. But you haven't changed this, right? It was working before. So, there's not too much that could break there.
Yes, I saw that as well. So I checked the IAM policy. I looked into encryption, so I thought maybe it's an encryption key that I don't have access to, but there's no encryption key involved. IAM policy looked fine. I really couldn't figure it out. I turned on CloudTrail data events to see if something is going on there. So the requests are coming in. And one thing I realized then is when I looked into the CloudTrail logs, I found one thing that caught my attention. This was the request coming in for putting an object into the bucket was also setting an object access control list property. And basically it set the object ACL to public read. So this is the default that Mastodon uses to make sure that when you upload a new object to S3, it's readable from anywhere. But because I reconfigured my S3 bucket and I'm using one of the modules that probably you wrote, I automatically turned on block public access for the bucket, which is a feature of S3 that prevents accidentally publishing information to the world. And you can turn off basically those object and bucket access control lists. And there's even a configuration which is called block public access control lists. And when you turn that on, you will get an access denied if you put an object with a public read object access control lists configuration. So that is what happened. And actually,
I mean, wasn't there like a big initiative that AWS kind of announced that they will improve their error messages? I mean, why can't they tell us that, okay, this is, I mean, I don't know if it should be an access denied error, but if it's an access denied error, just tell us it's denied because the ACL you set does not match with the block public access settings or something.
That's a good question, Michael. I thought about that as well. I don't know. It could also be related to, because the Mastodon software is basically written in Ruby. I think it's Ruby, yes. And they're using some wrappers around the S3 access. So maybe the real error message gets hidden somewhere. That's possible. I don't know.
Okay, I see.
I couldn't find it in the debug logs. But that's what I found. And then the funny thing is then I was trying to figure out how do I get rid of the public read access control list for my object. And it turns out that this is an undocumented configuration environment variable. So I went through all the code in the Mastodon repository and I found it there, luckily. So there's an S3 _ permission environment variable, and you can set that to private, and then everything works. Okay. Yeah, so this was really crazy.
Well, that's cool. At least there's a setting.
Yeah,
right?
I was glad about that. Yeah, I think it shouldn't be the default, the public read, but that's another thing. And I made a pull request to update the documentation on Mastodon, and I learned a new thing about S3 access denied errors. So you need to check if you did enable block public access, and then check whether the one that creates the object is using a public read access control list setting. Yeah, so that's my learning. Took me about 2 hours. You totally wasted time because I just wanted to to publish a new post, and then I run into that. But that's what it is when you run your own instance, right?
That's how it is. All right. So I was also running into issues, Andreas, and this time I was testing our Bucket AV antivirus for Amazon S3 software in the new region, AP Southeast 4. So that's how's it called? I don't remember the city name actually. Is it Melbourne? I think it is.
Yeah.
All right. So what I did is I just created an AMI there that was working, and I was spinning up the CloudFormation stack, and then I was running into all kinds of errors. And that kind of led me to thinking a little bit about the variances between AWS regions. So this is what I want to share here. And one thing that I discovered, I think it was last year, that different regions have different quotas. And this is especially true for services like SNS, SQS, and EventBridge, where the maximum allowed of messages that you can send per second varies very significantly. So for example, US East 1, which is a very big region, has very high quotas, while smaller regions have much lower quotas. So if you, for example, deploy your solution to a big region and your fallback region is a much smaller one, then you will have a hard time if you reach one of those quotas actually, because it will just not work in the other region then. So this is very important if you plan, or if you have like fallback plans if the main region goes out. And I think everyone that runs in US East 1 has kind of a fallback, right? Because it is often, or it's the region that is most often impaired by larger outages. So watch out for that if you choose a backup location that, at least if you're using one of those services that have region-specific quotas, you will not run into issues there. And the other thing that really kind of annoys me is that current generation EC2 instances are, like, the types are not available in all regions. So for example, in the new region, we don't have the AMD-backed instances. So for example, we don't have M5As. And I mean, if it's a current generation region, I kind of expect that it's just available, but it's not. So don't be misleaded by the term current generation. And also what I was experienced this time, and this is why kind of the whole topic came up, is that it seems to be a new kind of, I don't know, I never experienced that before, so it must be, I think, new, that some features are disabled in some regions. So for example, we deploy an auto-scaling group that has a spot allocation strategy that we set to capacity optimized prioritized, which is a whole, I mean, the whole thing is a topic on its own, but we ignore what it actually means. But it turns out that this specific spot allocation strategy is not available in this new region. So it is just missing. And I was a little bit frustrated because, I mean, if I can now no longer deploy my CloudFormation template to different regions, then it gets really, I would say, at least harder than in the past, because I was never running into issues like this. And another thing that we learned, Andreas, with the Mastodon project is that some features are not even available in all availability zones. So for example, we had someone running into issues deploying an application load balancer into a specific availability zone. And this is really, I mean, this variance is really increasing the complexity if you want to have one solution that works in multiple regions, and even the whole tool CloudFormation is not able to deal with that problem. So Terraform is much better because you can query some of the parameters with a data resource, but in CloudFormation you're totally lost. So you basically end up with custom resources that check for certain values and then return them in outputs, and then you can kind of try to work around all those problems. But yeah, I don't think that we have tooling to deal with the problem, and I also think that AWS shouldn't introduce those problems to us at the first place. So yeah, that's it, Andreas. Yeah, that's what I learned. Yeah. So it's really hard these days to run your stuff in multiple regions. Yeah,
I think our scenario is maybe special because with Bucket AV we aim to support all available AWS regions. So our solution or application has to run in all those regions. That's probably that's not a usual thing to do for most for most companies probably, but yeah, for us it's important. And I think the only way around it is to run our integration tests in all. Actually, you have to run them in all regions, or at least in the new regions that you add, to make sure you're spotting all those specialties. That's really hard, and that's quite complicated to do as well, and quite expensive to do. So if you have to go over all those regions, and as they are adding more and more regions, the situation gets probably worse over time.
Yeah. And I mean, we can spot the issue, and we can do that today, right? But then there is a problem how to fix it.
Yeah.
Because in some situations,
how do you do it in infrastructure?
With CloudFormation, it's not so easy. For example, you don't know the availability zone ID that you deploy to and things like that, and it's really crazy.
You definitely need that. Yeah. Yeah, we should try to raise some awareness for that. Maybe there are not too many having that issue.
Yeah, and it's a new problem, right? I mean, I hadn't. This is a problem that I'm running maybe into since maybe a year or so. So I was never running into this issue a couple of years ago. So it must be a new problem, or I haven't experienced it before. But I mean, we use the same template, the same product, and so for a couple of years. So I don't.
Yeah, maybe another thing is maybe it's worth waiting a few months before activating a new region, because maybe some others will run into that problem.
Yeah.
And AWS
same for new
fix it.
services.
Yeah.
But I mean, what's the strategy? I mean, we release a new region and all customers wait for you on 1 year until it's done. Or I don't know. Maybe you just wait for another year before you release it. But
yeah. So I think smaller regions. So I've seen someone complaining on LinkedIn about the new region in Switzerland. I think it was released a few months ago. And it seems to be that this region is missing many AWS services, and they're not deploying them to the region. So probably the issue is worse in very small regions where there's not too much demand, and there's not too much focus of AWS to fix those things. Yeah. Okay, Michael. Next topic is self-hosted GitHub runners on AWS. So I was working on a project together with one of our consulting clients, and the goal was to run GitHub runners on AWS. So self-hosted GitHub runners on AWS. And what I wanted to share with you is basically the overall architecture that I came up with for that. So the thing is, so overall, so with all those tools like Jenkins, GitHub, GitLab, and so on, you need those runners to for running your build jobs. So you need some compute capacity to run all your build jobs. And typically, such a CI/CD infrastructure is not utilized 24/7. It's typically utilized during the working hours of the developers. And you might have huge spikes in your workload. So, Michael, I remember we have one of our very first consulting projects where we have been working there. There was a CI/CD infrastructure. And as a consultant, I think it was Thursday or Friday evening when I had to pick my train back home. And every time I tried to deploy something before leaving, and this was really hard because the CI/CD infrastructure was under high pressure, and executing a job just waited hours to execute because there were no workers. So it is hard to basically scale the infrastructure that you need for that. You don't want to over provision. You don't want to wait too long. And if you're not using code build or something and you run that your own, that's a thing you need to cover. And I thought, okay, let's look for the simplest possible solution to achieve that. And my idea was, okay, so let's just launch a new EC2 instance for each GitHub job that is waiting for a runner. And of course, the downside of that is it takes a little bit. So in my experience, it takes about a minute. So after you start the job until it starts executing on the EC2 instance. So there's maybe room for improvement, but that's how it is right now. And what I came up with is the solution that GitHub sends a webhook event to an API gateway, which forwards it to a Lambda function. And the Lambda function then just launches an EC2 instance based on a launch template. So this spins up the instance with the GitHub runner pre-installed, and the GitHub runner then registers itself at the GitHub server and then starts executing the job. So that's basically how the thing looks like. There's one special thing. So to register a GitHub runner, you need a token. A token is only valid for, I think it's an hour by default. So you need a mechanism to generate those tokens automatically to be able to register a new runner. And so I did that by creating another Lambda function that the EC2 instance is invoking during startup and gets the token from. By doing that, I did not have to add the private key that is used for that, for the GitHub app that is allowed to do so. I didn't have to add that private key to the AMI, which is, I think, a good idea because, people are executing their jobs on this machine. So, this is not really a safe space, I would say. So this was my solution to that. And I think this is a really a simple approach. So it took about 2 or 3 days to really build it and to become production ready. And now it just spins up new machines on demand. They're picking their job. And then what how to get rid of the jobs. So GitHub runners have an option that is called ephemeral. So basically, the GitHub runner will only execute one job, and then it will just shut down or exit the process. And what I'm doing is I set this is called, how is it called? It is called the EC2 instance initiated shutdown behavior. This is the configuration for EC2. And this means when you halt the system from inside the operating system, this tells EC2 what to do with the virtual machine. By default, this is stop. So that means the instance will stick around. You could start it later, but you can change that to terminate, which means whenever the operating system halts, shutdowns the operating system, it will terminate the instance. And that's what I'm using here. And this also allows me to use shutdown instance in 60 minutes. So when the instance starts, the first thing I do is I set shut down this instance in 60 minutes. This is basically then the timeout for the job. This is, I think, also an interesting approach. Yeah, so I think this is quite an interesting solution. And what I want to ask our listeners is, are you running self-hosted GitHub runners on AWS as well? If so, how do you do so? Why do you do so? Please write in and share your insights. I'm keen to learn about different scenarios. I'm thinking about building this out into a project as well.
All right, Andreas. So if I understand you correctly, then basically what happens is in user data, you set shutdown minus H 60 minutes, and then you run the GitHub runner, and because it exits it after it's done, you then execute the command shutdown minus H now.
Yeah. So that's more or less how it works. Yeah. Exactly.
Okay. And then you also have to get the token and stuff, but that's the simplified version. All right, I see. Okay.
Yeah, and I like it.
Cool
I like that it's really simple, so I don't have to manage a pool of instances. I don't have to think about how to update the instance, how to patch the thing. I can just build a new AMI, update the launch template, and the next job will start with the new configuration. So that's, I think, really cool.
And I also like it. I mean, it's fully isolated, so each job runs on a very clean state.
Starts from
that's a good thing.
Yeah, and actually, Michael, I learned one more thing about GitHub Actions that I didn't know before, because so with GitHub Actions, so when you have to do things like Terraform, TerraGrunt, or whenever you need some kind of a tool, a library to execute your stuff. So I was always in trouble because there are GitHub Actions available that basically configure you or install you Terraform each time you run your actions. I don't like all these actions because this is a public repo. Someone maintains a GitHub action. So it's just one guy that has 3 months ago or 3 years ago published this GitHub action, is not maintaining it. And I'm trusting this this user to make sure I'm not injecting any bad code into my pipeline, which has access to my AWS accounts. So in general, I don't like to use those GitHub actions to set up those things. And what I found out is you can use a concept that I like really much for CI/CD is you can basically run your jobs inside containers as well with GitHub Actions. So for your jobs, you can specify all those I think it's called tasks in GitHub. All those tasks should run inside this specific container. Then you provide the image, and GitHub Actions will download the image and start a container out of it. And by that, you can bring your own container image with the things included that you need. And each project can bring its own container image, so they're not sharing any dependencies and stuff. So I like this very much, and it again isolates the whole thing. This was a good approach with Jenkins. It's a good approach, I think, on every CI/CD tool that you're using, and I want to introduce that to our GitHub Actions as well.
Yeah, it also makes it very clear the dependencies that you need to build your project, because otherwise you rely on this AMI, and if it's then shared by others and things, and someone changes it, it all breaks that
or in worst case, you download the Terraform binary every time you run your build job if it's not cached and
that's
stuff like that.
It's super inefficient as well. That's right. But I mean,
and it depends on third parties that I do not control. So imagine I need to download the Terraform, TerraGrunt, AWS CLI, and so many things can go wrong. So yeah, I love that it's now included into one container image.
Yeah, that sounds like a good plan, and it's the same that we did, I mean, with Jenkins as well, right? So
yeah.
Okay, so I have one last thing, Andreas. Do we have time for that? Or
Sure, we have.
All right. So I was fixing a bug that I was experiencing. Again, this is also now referencing Bucket AV, the antivirus for Amazon S3 product, but it basically is a problem that occurs in a scenario where you have an SQS queue with EC2 instances acting as the workers, and these instances are managed by an autoscaling group, and you autoscale the autoscaling group based on the number of messages available in the queue. So what we do is we scale up our fleet based on approximate number of messages visible, so that's a CloudWatch metric, and we just scale up our fleet. But this is not actually the topic. So the scaling up is working fine. So what we actually use is we use step scaling. So if our queue has like a few items, we add one instance. If it has much more items, we add like more instances basically in one shot. But this is not what I'm going to talk about today. What I'm going to talk about today is the scale in. So what happens when we have no messages in the queue anymore? So how do we get rid of the workers? And what we did before I experienced the problem was that we also used the same metric, approximate number of messages visible, to scale down the fleet if this metric was 0. So that was basically the rule. So there was a CloudWatch alarm, and it says, okay, if this metric goes like small, or how's it called, less than or equal to 0, I don't know what exactly the terminology is, but basically if it's 0, then trigger the scale in action. And the problem now is that we have a file that basically the worker takes a lot of time to process this file for some reason. So like I think it's 12 minutes or something. So what happens is the worker picks the message from the queue, it starts working on it, and then what also happens is that the approximate number of messages visible goes down to 0 in the moment where you pick it from the queue. And so from a perspective of the autoscaling rule, it looks like that there's nothing to do anymore. And that's why after, in our case, 5 minutes, we kind of terminate the instance. But the instance is still working on the job. So what happens is, the instance is terminated. Then when we pick a message from the queue, we say that we either confirm within 60 seconds or extend the period we are working on it for another 60 seconds. So within 60 seconds, SQS will recognize, okay, this file was never acknowledged. It pops up again in the queue, message number, the approximate number of messages visible, whoop, goes up to 1. We scale up, we add another instance from 0 to 1. We start working on it. 5 minutes later, we kill it, boom. Takes another minute, it appears in the queue again, and so on and so forth until we reach our maximum number of retries, which is, I think, 3. And then we will move it to the dead letter queue. Okay, so I was thinking about how to fix that problem, because what we have in our backlog is for other scenarios a very similar problem. But to fix this specific scenario where the problem occurs because we scale down to 0, I figured out a very simple solution. And that solution is that I combine 2 metrics to trigger the scale in actions. So I still use approximate number of messages visible, but I also use the metric approximate number of messages not visible. And this contains basically the files that are in progress. Or the messages that are in progress. So you can use metric math to just kind of add those 2 metrics, and then I get a much better view of the tasks that are in progress as well as the ones that are sitting in the queue. And if this then is down to 0, then I can really shut down the instance. So that was the simple solution for this very specific problem. So an alternative approach that we have in our backlog that also works for, like if you scale in from 5 to 4, for example, is to use an autoscaling group lifecycle hook. So there you basically get the information, okay, the autoscaling group wants to terminate the instance, and now you have time to do something before you kind of acknowledge that it's now time to actually terminate the instance. So this is another approach, but the problem is it is much more complex. It adds a lot of other problems. So for example, what if the mechanism that kind of acknowledges this is broken? So there is a timeout somewhere. So if the autoscaling group does not receive something from you within, you can configure that 30 seconds or 300 seconds. It just goes on to terminate it and things like this. But so I just wanted to fix that specific problem, and I just achieved that with metric math. A very simple solution, I think, for the problem, and it works perfectly. And that's the last lesson that I learned last week, Andreas, that I want to share.
Yeah, very cool, Michael. So I think it's important to mention that now you're combining the number of messages visible, that's the number of messages waiting, and you're combining that with the messages not visible, which is the ones that are currently processed. You're combining those two metrics. But it's important to note this is only working for the scale in events, so to scale down the number of instances, because for scale up, you only have to look at the ones waiting in the queue. So that's important, I think. Yeah, because that was my first thought when you described that to me. So how do you make that happen? But yeah, you just do it for the scale in, not for the scale out, and then that's working fine. Very cool. Yeah, very simple solution. Again, I think today we had two simple solutions to complex problems. I like that a lot. I love those simple solutions.
Yeah, that's great.
Okay. So yeah, then that's it. We will be next week with the next podcast episode. Subscribe to our newsletter, the podcast, or the YouTube channel to make sure you're not missing the upcoming episode. We're looking forward to your feedback as well. So, for example, write into hello@cloudonaut.io or find us on LinkedIn or Mastodon. So looking forward to your feedback about the podcast and the topics we discussed today.
Yeah, and also we want to thank all our supporters who make this show possible. So please consider supporting our work. So there are a couple of options. So there's one-time or recurring donations available. And you can find all the links in the video description or the show notes. So thank you very much for watching this. And the last thing to say is bye. Have a great day.
Bye.